This is the BMS Tour 2, operating on the bench at the moment with 50 cells, all connected up into the two battery blocks for the Honda Insight PHEV conversion. Just a quick run through. Got a couple of fans on top of each of the blocks. These aren't to cool the cells, they're actually to cool or remove the heat which is generated by the balancing resistors which are on each circuit board. Each of the 50 circuit boards monitors the individual cell voltage, activates the load whenever the voltage goes over the set point. The slaves are all connected in parallel with the master bus, but in series with the slave bus. So what happens is the master board sends a signal down the slave wire here, the data wire. That's received by the first slave in the string, which acts on the information and dumps its cell voltage data onto the bus, then passes on the message to the next cell in the chain. Now at the moment almost all the cell boards are bolted down, however one or two aren't, because they are still waiting high current connections. There's an example here, that's the plus and the minus main pack connectors. So if I disturb the boards here, the system will go offline. And you can see it's now indicating, or was indicating, an error as the cell 1 error, and in the background you can hear a slight clicking, and that's the audible alarm. Just that to get it back on again. Now the system is back operational again, system nominal as the message. It is calculating the voltage, 167.6 volts. The average cell voltage is 3.35 volts. Just having a look at the other leads. This is the block which is actually going at the front of the vehicle, or at the front of the two blocks, I'll put it this way. Two connectors, one data connector, temperature sensors, fan control, etc. This one connects to the OEM Honda Insight battery control module via another adapter socket. It provides 6 voltage taps for the cells in the same positions as they would have been in the original nickel metal hydride OEM pack. Now behind the display here is an interconnector between the two packs for the data, so that the data comes into the first pack here, goes around the 25 cells, across into the other pack, and around the 25 cells. These are just two low voltage 12 volt fan connectors. At the moment the system is operating. I am going to turn the light off just so if you can get an idea of the slightly different variation in slave operation to the previous one. Now I'm hoping that you can see the LEDs circulating round. Instead of all activating, which they did previously as soon as the first one received a data request, they're now activating sequence, which just helps to share the load, make the current consumed slightly more equal for the ones at the end of the string. And you can see it's taking about a second to go around the whole 50 cells. I've got the system set on the slowest speed at the moment, 1200 baud, serial 8N1 communications. This is obviously still development. If it proves reliable at this speed, I shall double the speed, 2400, and then potentially go to 4800, which is the maximum speed for the slave board. So that would, a fourfold increase in speed. And that's where we are at the moment. Just the heavy current connections to do. Hoping to do those in the next few days, and hopefully get the system installed perhaps within the month. Thank you.